All right, so we already took notes on the rules for significant figures, but this tutorial handout summarizes them nicely. There's the 4 rules, maybe expressed a little bit differently than we wrote down earlier, but you can see some good examples given here. For instance, all non-zero numbers are significant. Zeros that are sandwiched between other non-zero numbers are significant. If they are leading zeros, then they are never significant. They're just placeholders. And if they're trailing zeros, then the decimal point makes them count. The decimal point is indicating that somebody's taken the time to measure to that placeholder value. So comparing those 3 is a good example to look at. The next topic that we want to cover is how do you round numbers to a new number of significant figures? For instance, if we wanted to round the number here, 254.67 to 3 significant figures, it should make sense that the furthest left numbers are the most significant. So we're always going to look at the furthest left ones we want to keep. 3 significant figures here would be the 2, the 5, and the 4. And the only question is, does this 6 cause that 4 to round up or not? In other words, I'm going to look 1 digit beyond the sig figs I'm keeping, but not more than 1 digit beyond that. And 6 is going to cause that to round up to a 5. In other words, that's going to be 255. In the next example, we want to round to 2 significant figures. So these are the 2 significant figures I'm going to be keeping, at least those 2 placeholder values. I'm only going to look 1 digit beyond that. Don't be confused by this 9. The 4 does not cause that 3 to round up, so I'm going to round this to 1,300. Do not put a decimal point there, because if you did, that would be 4 significant figures, not 2. Remember that a decimal point makes trailing zeros count, but without the decimal, that only has 2 significant figures. So somebody is trying to communicate here in writing that number that it's about 1,300. It could be 1,270. It could be 1,310. But we know the hundreds place with precision. If you see a number in scientific notation, it's only the base that's going to be considered. So rounding this to 3 significant figures means looking at those 3 and then wondering if this 5 is going to cause that to round up. Yes, it will. That would round to 1.45. Of course, we have to keep this part to indicate that that's 1.45 million, not just 1.45. If we wanted to round this to 1 significant figure, notice that we're only going to look at that 3, and we're going to get 1 times 10 to the 12th. That is 1 trillion. And we're not sure about the other placeholder values here. And then finally, rounding this to 3 significant figures is essentially just going to lose the decimal point. And I determined that by looking at the 3 most significant figures that I'm going to keep. The 0 does not cause that to round up. So that's how we round to a new number of significant figures. Now, why might we do that? An example we looked at before was a density calculation where I think we took something like 57.9 and divided by 22.45. And you'll notice that one of those numbers has 3 sig figs and the other has 4. Well, the rules we're going to learn say that we can only keep 3 sig figs because that was our less precise number. So that's what's limiting our precision. How would I round 2.57906 to 3 significant figures? Just like I was doing here, look at the 3 most significant figures. That 9 causes the 7 to round up, and that's why I wrote 2.58 as the answer to that question. So next we're going to talk about how to know how many significant figures to round our answer to. On the back of the page, those rules are explained. The rules are going to be different if we're doing multiplication or division versus doing addition or subtraction. If we're doing multiplication or division, we cannot have more significant figures than any of the numbers we're multiplying or dividing. In other words, whichever one of the numbers we're working with is less precise, the one with fewer significant figures, that's the one that's limiting our answer. Now, you can see the example that's given here has one number with 3 sig figs and another one with 1. When I do this multiplication, my answer cannot have more than 1 sig fig, and so I'm going to round that to just 1 significant figure. Now, we'll practice that a little bit, but I want to introduce the rules for addition and subtraction while we're at it. And then we'll practice all of these together. When we're adding or subtracting numbers, we're not going to pay attention to the number of significant figures per se, but rather the placeholder value of the numbers we're adding or subtracting. So you might look at these two numbers and say, well, that has 5 significant figures and that has 5 significant figures, so can't I keep 5? But with addition and subtraction, it's more important to consider that while this is given to the nearest hundredth place, this is only given to the nearest whole number place. So we can't possibly report an answer to the nearest hundredth place. This has 2 digits after the decimal. This has none. So the answer cannot have more than 0 digits after the decimal. The idea is we're only looking at placeholder value, right? The least precise placeholder value we have here is whole numbers, and so our answer cannot have anything more precise than whole number values. Last but not least, I want to mention that the words accuracy and precision, while we've defined them as correctness and exactness, the word precision can also refer to how closely clustered a set of measurements are together. So for instance, the greatest example here is this one in the bottom left. That would be considered inaccurate but highly precise, right? You're throwing those darts in the exact same region every time, but they're not on the bullseye. That means that your throwing is very precise. There's not a lot of deviation from one dart to another, but it's not hitting the true value, so to speak, or it's not hitting the target. So we're going to practice rounding to a new number of significant figures by using rules for multiplication and division versus addition and subtraction next.